Hey everyone, and welcome back. So far, we have built a text-based chatbot with memory. That's a solid foundation. However, modern applications require much more than that. So in today's video, we are going to explore three concepts. Streaming responses for better user experience, structured responses for reliable outputs, and multimodality to process text, image, and audios all together. In the last episode, when we invoked the client, we got our response all at once, but usually in AI chatbot this isn't the case. You get the response token by token, not everything at once. You get the response as it's being generated. And this makes it for a better UX and also reduces latency. So let's see how to stream responses like this in Datapizza AI, which is fairly straightforward. So here I have the code from the last time. We just invoked the client and then printed the response. Easy, and the response comes out all at once. Now, if I want to stream the response, I need to use the stream invoke method, which every client has. Okay, so what we are doing here is calling this method, and instead of getting the response like we did before, we are getting an iterator. Response in this case is an iterator. So it's a Python object we can iterate over. So in this case, for chunk and response, and we print chunk.delta. Delta contains the new token that was generated. And this way, I can print token by token my response. So if I run this code, as you can see, my response was generated in a streamed way. So as you can see, I did not have to wait until the whole responses were generated. So this makes for a way better user experience. And you can also, for example, compute the time to the first token. So that's it, you are streaming responses. This is the key element to build responsive and user-friendly applications. Now, let's dive in structured responses. Many, if not most LLM-based applications usually require some kind of predictable output, some output that adheres to a certain format. Maybe you are doing text classification, maybe you are doing a natural language to structured data. You need something that is reliable and that is always in a predictable format. One way to do this is to ask the LLM to output a certain JSON with a certain structure, like we did here in this code. So let's say that I want to take some input movie description and I want to extract some data, let's say movie title, genre, year. So I just want to transform this description in a structured data. This approach is very brittle and does not yield good results because you are basically hoping that the LLM matches the structure of the JSON that you asked for, but the LLM may add comments, it may add backticks, for example, or it just may format it differently. So this is not a very good way of doing this. However, enforcing stricter data validation in Datapizza AI is extremely easy. We can do it using Pydantic. To do this, we need the Pydantic library installed. If you don't have Pydantic installed, you can just do pip install Pydantic. I already have Pydantic installed, but you may need it. Pydantic is not part of Datapizza AI, it's just a very popular Python library that has nothing to do with the framework. But still, we are using Pydantic because it's very robust and helps us create very strong data types in Python. So now, instead of providing the JSON in a prompt, we create a Pydantic base model. Here I have a movie description base model, so I define the movie title, genre, year, director, and actors. Actors itself is a list of other Pydantic objects, in this case the class actor, which has name and role. So you can also do nested Pydantic objects, you can go crazy with it. Now, the other thing I need to do to modify is to change this prompt. I don't need this JSON anymore. So in this case, we provide the input prompt. In this case, given an input movie text, output a movie description object, and also we provide the output class. So we are telling the model to try to follow that data class. So we can get our movie description by accessing response.structuredData at the 0th index. Now, movie description is a structured object of the type movie description. So what we can do is access the attributes of this object. Basically, we can print all the individual attributes. We can access them. So here, let's use the keyword argument just to be sure, and movie title, I was using the wrong key. Okay, so let me correct this prompt, which is too generic in my opinion, and also make sure to actually provide the movie because... Okay, so here we have the description of Interstellar and our prompt. As you can see, I printed the whole object, so movie title Interstellar, genre science fiction, year 2014, director Christopher Nolan, so and so on. Now I also have all these single attributes, and that's how you build structured responses with Datapizza AI. See the difference with the JSON example we had before? Here you get full IDE support. You get a strongly typed Pydantic object. And if for some reason the model is not able to match the type you gave it, you will get a clear validation error. And that's how you build production-ready application. You define your data model once, and then let Pydantic enforce it everywhere. Okay, now let's explore multimodality. Multimodality means processing different kinds of data, text, image, audio, with the same model. Which modalities are available depends on the model. Most modern flagship models usually they offer two modalities, text and image as input. There are some models which also offer audio as a modality. Now, let's start with images. Datapizza AI makes it extremely easy and straightforward. We can provide images basically three ways: as a URL, with base64 encoding, and with path. Let's see the first method. So I will start again with our basic client invocation, just to show how easy it is to implement this. Okay, so we have our OpenAI client. Now, to process an image object, I need to import it first. So this way I can create media. Here we can basically encapsulate our image so it's ready to be fed to an LLM. So to create a media object, I need to provide an extension, the media type, in this case an image, and the extension is going to be JPEG. And as I said, we have three ways of providing the image. In this case, I'm providing the image as a URL. So source type URL, and then I'm going to provide the actual URL. So we don't need to download the image or anything. So this image is the last image taken by NASA's InSight rover on Mars in 2022. Now I'm going to ask the model, what does the image contain? I need to import two additional types. So media block. So now that we have an image, we need to wrap it in a media block. We also need to wrap our text in a text block. Why do we have to do this? Because when we have different modalities, we can mix and match them by actually building the input in blocks. In this case, I am providing a list as input to the model with a text block and a media block. I can put the media before, the text after, I can put many images, I can interleave image and text. I am free to do whatever I want this way. I'm not constrained to a text input. I can give the model whatever I want. This is the extreme flexibility that blocks give you. We have already seen blocks in the previous episode when building the memory for the model. Okay, here we have the output. So the photo shows a dusty, the reddish-brown barren landscape, so and so on. So it's describing the image in an extremely detailed way, and we can see that the description fits the image. Perfect. So if we instead have a local image, we can load it locally. We can do it two ways. We have to encode it in base64. So first we import base64, and then here we are loading a local image. Here I have an image of the Tarantula Nebula, and I'm going to load it in base64. Here I have to change source type to base64 and provide the actual image data. If we run the code, we get the output. And as you can see, the output looks correct. Perfect. So the third way of doing this would be to immediately provide the path to Datapizza AI without actually loading the model in base64. We can just do this by removing this and providing the path. So we can just do this by setting source type as path and providing the actual path. We don't need to do anything else. So this leads to a much cleaner code. So if I now run, again we get the output. These three ways of loading a media object are not constrained to images. We can do the same with audio. Obviously you need a model that is able to process audio. Let's use in this case Gemini Flash. And here I have an audio of fire cracking. I want to provide this audio to the model and ask it what's in the audio basically. So what we are going to do is just setting the extension, setting the media type, audio in this case. The source type we can use path, we can encode it in base64, or we can use URL, so the same as images. And then the source. So I can ask it to describe the audio. Let's see. And here I have my output. So primary sound, sizzling and hissing, so and so on. So the audio was processed correctly and interpreted by the model. Now, if you remember, when we built our chatbot with memory, we updated the memory using text blocks. You are not constrained to text blocks. You can also add media blocks to the memory. You can basically build your multimodal memory if you want, and build a chatbot that has multimodal capabilities. Let's do a quick recap of what we covered today. We have seen streaming responses for a better user experience. We've seen structured responses enforced by Pydantic to have a reliable output in a certain type. And then we also explored multimodality, and this allows a new realm of possibilities, for example, document analysis, image captioning and classification, and so on. Now it's your turn to experiment. Try to build maybe a multimodal chatbot or a document analyzer. The possibilities are endless, and this is only the foundation for endless applications. If you found this helpful, drop a like and leave us a comment. Or even if you are stuck somewhere or something's not working, also drop us a comment and we will try to help you. See you in the next one. Bye.